Our lesson today is going to focus on two-step equations. All right, the last lesson was about one-step equations where it took one step to isolate the variable. Today it's going to take two steps to isolate the variable. And the same rules that we use for one-step equations are going to apply to two-step equations. Remember the equation's golden rule. Do to one side exactly what you did to the other side. Okay? Do to one side exactly what you did to the other side. Okay? This will ensure that you keep the equation balanced. Okay? So if you add on one side of the equation, add the same amount on the other side. If you divide on one side of the equation, divide by the same amount on the other side. Remember to keep your equation balanced. In our first example, we have this picture using the algebra tiles, and what we need to do is be able to determine what the equation represents. Okay, so we have our equal sign. On the left-hand side of the equal sign, notice right here that we have three rectangles. The rectangles represented our variables, and so I see that there are three of them. So underneath the word algebra, I'm going to start by writing 3x. Okay, the three variable rectangles there are going to represent 3x. I'll use x as my variable. And then next to that are 5 yellow squares, which is the constant positive 5. So the left side of the equal sign is going to say 3x plus 5. And then I'll write my equal sign. And on the other side of the equation, I have 11 yellow squares. So 3x plus 5 is going to equal 11. Remember that the goal of an equation is to isolate the variable. We need to get that variable term all by itself. So in our picture, we've got to get those rectangles all by themselves. The variables are on the left-hand side of the equation. They're not alone. They have the 5 yellow squares there. We would want to take away those 5 yellow squares, but if I do that on the left side, I have to be able to do the same thing on the right side. Fortunately, on the right side, I can see that I have enough there to take away 5 yellow squares as well. So the first thing I'm going to do is cross out 5 yellow squares on the left. 1, 2, 3, 4, 5. And now I need to do the same thing on the right-hand side so that my equation will stay balanced. 1, 2, 3, 4, 5. I took away 5 yellow squares from each side. Algebraically, what I've just done to each side is subtract 5. So underneath of the word algebra, on the left-hand side, I subtracted 5. And then I also subtracted 5 on the right-hand side. Bring your equal sign straight down. On the left, when we have 5 minus 5, that leaves 0, leaving us with just the 3x. And we can see here that only my 3 variable rectangles remain on the left-hand side. On the right-hand side, when you do 11 minus 5, that leaves you with 6, and we can see the 6 yellow squares. So now the equation says that 3x is equal to 6. So our variables are alone, but we have multiple variables. I don't want to know the value of 3x. I want to know the value of just 1x. So what I'm going to do is split my left-hand side into groups so that each group has only one variable in it. So I'm going to have to create 3 equal groups on the left-hand side. Since I made 3 equal groups on the left-hand side, I'm going to have to make 3 equal groups on the right-hand side. There are 6 squares there. That means that each group is going to have 2 squares. So there's 1 equal group, there's a second equal group, there's my third equal group. And now if I match it up, I can see that one variable would be equal to positive 2. So what we did on each side was divide into 3 equal groups. So underneath the word algebra on the left, 3x we divided into 3 equal groups. And then on the right, 6 we divided into 3 equal groups. 3x divided by 3 is 1x, which is the same as x. And 6 divided by 3 equals 2. So we think that x equals 2. The way that we're going to make sure that x equals 2 is by doing a check. Remember that the first part of a check is to rewrite the original problem. In this case, 3x plus 5 equals 11. Since we think that x equals 2, replace x with that value. 3 times 2 plus 5 equals 11. And now we have math to do on the left-hand side. I see multiplication and addition. Remember, with order of operations to multiply first. 3 times 2 would give us 6. So now it says 6 plus 5 equals 11. And when we do the addition, 6 plus 5 is 11. So 11 equals 11, meaning that the equation checks. And I know that x had a value of 2. Looking at example number 2, again, the first thing that we have to do is come up with the equation that's represented by the picture. On the left-hand side of the equation, I can see 15 yellow squares. So I'm going to start by writing underneath the word algebra, 15 equals. And now I'm going to look at the right-hand side of the equation. I see 2 green rectangles, which is going to represent my variables. I'll use x again. Since there are 2 of them, that's going to be 2x. And then I also see 3 yellow squares, which would represent the constant positive 3. So the right-hand side is going to say 2x plus 3. Our goal, as always, is to try to isolate the variables. So we've got to get those rectangles all alone. The variables are on the right-hand side, but they're not alone. I have those 3 yellow squares there. I would like to take those away, but I have to also be able to take away 3 yellow squares from the left-hand side as well. Fortunately, looking at the left, I can see that there's more than 3 yellow squares there. So we're going to go ahead and take away 3 yellow squares from each side. Let's start on the right. Okay, I'm going to take away 1, 2, 3 yellow squares on the right. And now I'll do the same thing on the left. 1, 2, 3. Algebraically, all right, we just took away or subtracted 3 from each side. So on the right, I subtracted 3. And then I also subtracted 3 on the left. Bring your equal sign straight down. On the right-hand side, 3 minus 3 is 0, leaving us only with the 2 variables. So 2x is on the right-hand side. And then 15 minus 3 on the right-hand side leaves us with 12. There are still 12 yellow squares. 12 equals 2x is our new equation. Okay, but again, I don't want the value of 2x. I only want the value of one of the variables. So on the right-hand side, I'm going to split it up so that there's only one variable in each group. So I need one group, I need 2 groups on the right, which means I need 2 groups on the left as well. Since there are 12 yellow squares and I need 2 groups, that means I'm going to have 6 yellow squares in each group. So I'm going to create a group of 6 right here. There's one group of 6. And then I'm going to create my second group of 6. We get all 6 of them. There they are. So I now know that each variable is equal to 6. Let's show that algebraically. Okay, what we did to each side was divide them into 2 equal groups. When I divide 2x by 2, that gives me my 1x. And when I divide 12 by 2, that gives me a value of 6. So I know that 1x is equal to 6. Now let's do the check. Okay, remember that when you do a check, the first thing you have to do is rewrite the problem, which for us said 15 equals 2x plus 3. We think x is 6, so let's replace x with that value. 2 times 6 plus 3. And now on the right-hand side, I have some math to do. Multiply first. 2 times 6 is 12. And now when I finish the right-hand side, 12 plus 3 is 15. So 15 equals 15. And again, I know right here that x had a value of 6. In example 3, I again have to come up with the equation first. So looking at the left-hand side of the equal sign, I can see that I have 4 green rectangles, which I'm going to call 4x. I'll keep using x as my variable. And this time, notice that there are 5 red squares, which is going to represent the constant -5. So the left-hand side is going to say 4x minus 5. And then if I look at the right-hand side of the equal sign, I see 7 yellow squares, which is the constant 7. So our equation says 4x minus 5 is equal to 7. Okay, so again, we've got to get our variables alone. So looking at the left-hand side where the variables are, they're not alone. I've got those 5 red squares there. I don't want them to be there, so I would want to take away 5 red squares, except I can't do that to the other side. Remember, whatever you do to one side, you have to do to the other. Since there aren't 5 red squares on both sides, I can't just take away the 5 red squares. So I need to remember from last time that I'm going to have to create my 0 pairs in order to get my variables alone. Since there are 5 red squares on the left-hand side, which are negative, I'm going to have to put 5 yellow squares, or 5 positive squares, on the right-hand side, on the left-hand side in order to make 0. So let's go ahead and draw those in. 1, 2, 3, 4, 5, and I'm going to make them all positive, again, because the positive 5 squares and the red negative squares are going to make 0. Since I added 5 positives on the left, I have to add 5 positives on the right. So 1, 2, 3, 4, and 5. There's my 5 positive squares that I added on the right. Algebraically, since we added 5 positives to each side, let's go ahead and show that. I added 5 positives on the left, and then I added 5 positives on the right. Bring the equal sign down. On the left, when you take the negative 5 and the positive 5 and combine them, they make 0. All of this right here makes 0, so I can eliminate that from my picture. That means I'm only left with 4x on the left-hand side. On the right-hand side, when I add 5 positives to the 7 that were already there, that makes 12 positives altogether. So 4x equals 12. All right, so I need to get the value of just one x now. So I'm going to divide the left-hand side into groups where there's only one variable in each group. I need 1, 2, 3, 4 groups on the left, which means I need 4 groups on the right. 1, 2, 3, 4 groups. Okay, and I can see that each group on the right has a value of 3. So algebraically, we just divided each side into 4 equal groups. On the left, 4x divided by 4 is 1x in each group. 12 divided by 4 on the right was equal to 3. So I think x equals 3. Let's do the check now. Rewrite the problem. 4x minus 5 equals 7. I'm going to replace x with 3 since I think that's the answer. And now order of operations on the left, 4 times 3 makes 12. And then when I do 12 minus 5, I do get 7. 7 equals 7, which checks. So I know that x had a value of 3. In example number 4, I can see that my equation says 5 equals 2x minus 3. 5 yellow squares on the left. On the right, 3 red squares, which is negative 3. And then the 2 green rectangles is my variable term 2x. I again have to get those variables all by themselves, so I would want to take away those 3 red squares, except there's no red squares on the left-hand side. So just like we did before, we're going to have to create 0 pairs in order to get the right-hand side where the variables would be by themselves. Since I have 3 red negative squares, to create 0 pairs, I'm going to have to add 3 positive squares. 1, 2, 3. Okay, since I added 3 positives on the right, I also have to add 3 positives on the left. So let's go ahead and do that. 1, 2, 3. So algebraically, we just added 3 to both sides. Let me get rid of that mark there. I added 3 on the right, and then I added 3 on the left. Bring the equal sign down. On the left-hand side, I've got the 3 red negatives with the 3 positives, so all of this makes 0, leaving us only with the 2 variables. 2x is on the right-hand side, And on the left-hand side, when I add the 5 positives with the 3 positives, that makes 8. So the equation says 8 equals 2x. Now I need the value of just one variable. So on the right-hand side, I'm going to split it so that I have one variable in each group. So I just created 2 groups on the right, which means I need to create 2 groups on the left. There's one group. There's a second equal group. And I can see that each group has 4 in it. So I just divided both sides by 2. And when I divided the right side by 2, 2x divided by 2, there was 1x, one variable in each group. On the left-hand side, when I took the 8 and divided it by 2, there were 4 in each group. Let's do the check. The problem said 5 equals -3 plus 2x. I think that x is 4, so let me replace x with that value. And now when I multiply on the right-hand side, 2 times 4 is 8, so I have -3 plus 8. And then when I add on the right-hand side, -3 plus 8, I do get 5. So 5 equals 5, the equation checks, and I know that x had a value of 4. In the next few examples, what we need to do is explain the steps involved in order to isolate the variable. So looking at our first example, it says n divided by 3 plus 8 equals 14. Our goal is always to try to get the variable term all by itself. The variable term is on the left side of the equal sign, but it's not alone. It's got that positive 8 there, and we would want to remove that. In order to do that, the first thing we would have to do is subtract 8 from both sides. So let's go ahead and write that. We're going to subtract 8 from both sides. Okay, so let's go ahead and do that now. We'll subtract 8 on the left. We'll subtract 8 on the right. On the left-hand side, 8 minus 8 is 0, leaving us with the variable term n divided by 3. And on the right-hand side, if we do 14 minus 8, we get an answer of 6. So n divided by 3 equals 6. Okay, but now we need to get the value of 1n. Since n right now is being divided by 3, we're going to have to multiply by 3 on both sides. So we subtracted 8 from both sides, and then we have to multiply both sides by 3. So let's go ahead and show that. On the left-hand side, this looks like a fraction, so I'm going to multiply by 3 over 1, which is the same as 3. And on the right-hand side, I'm just going to write to multiply by 3. On the left-hand side, I've got a 3 and another 3 in the numerator and denominator, so those are just 1s. So this is 1 over 1 times n over 1, which is the same as our 1n. And when we do 6 times 3 on the right-hand side, we see that n is going to have a value of 18. Okay, take a look at the second example. 2n plus 8 equals 14. Again, let's get the variable term all by itself. It's on the left-hand side, but it's not alone. Again, it has a positive 8, a plus 8 with it. So the first thing that we're going to have to do, again, is subtract 8 from both sides. Okay, so if we do that on the left, we have to do that on the right. Bring the equal sign down. On the left, 8 minus 8 is 0, again, leaving us with just 2n on the left. 14 minus 8 is equal to 6. So now the equation says 2n equals 6. All right, but we don't want the value of 2n, we want just 1n, which means that I'm going to have to divide by 2. So then we're going to divide both sides by 2. Since 2 is multiplying the variable, we'll divide by 2. And I've got to do it on the other side as well so that my equation is balanced. On the right-hand side, 6 divided by 2 is 3. And on the left-hand side, 2n divided by 2 is just our 1n. So I know that our variable n equals 3.